Mountain bike physics, projectile motion, gap jump. Welcome back to mountain bike physics. Our mountain bike rider here has constructed a dirt ramp, and he's going to proceed with a gap jump. Go ahead and watch the video, and we'll introduce the 3 projectile motion problems at the end of the clip. Here's our problem. Our mountain bike rider launches his bike off a dirt ramp with an initial velocity of 12.5 meters per second, 30 degrees above horizontal. Solve the following 3 problems: hang time, height, and distance. Here's the solution for our first problem. The ball's hang time can be described as v sub y equals v initial times the sine of theta. When the ball lands, y will equal velocity of y times time minus 1/2 acceleration due to gravity times time squared, which will equal 0. We'll rearrange the equation to solve for t2, or t squared, excuse me. T squared will equal 2 velocity of y times time divided by acceleration due to gravity. Divide through by t, and we get t equals 2 velocity of the y-axis divided by acceleration due to gravity, which is equal to 2 times our initial velocity times the sine of theta divided by acceleration due to gravity. Grab your calculator, plug in the values. 2 times 12.5 meters per second times the sine of 30 degrees, 30.0 degrees, 3 sig figs, divided by 9.81 meters per second squared. Our bike's hang time is going to equal 1.27 seconds. Problem number 2 for maximum height will follow. All right, our maximum height will occur at half the hang time. So our hang time was 1.27 seconds, so half of that is 0.635 seconds. So y equals velocity in the y-axis in the y direction times time minus 1/2 acceleration due to gravity time squared. Plug in our values. Oh, excuse me, that becomes initial velocity times sine theta times time minus 1/2 acceleration due to gravity time squared. Now plug in our values. Initial velocity 12.5 meters per second times the sine of 30 degrees times our time, which is 0.635 seconds. Subtract from that 1/2 times 9.81 meters per second squared, that's acceleration due to gravity, times 0.635 squared. Answer, 1.99 meters. Our rider should be able to achieve a maximum of height of 1.99 meters. Find our distance. Distance is across the x coordinate. So v sub x is equal to initial velocity times cosine theta. Solving for x, x equals v sub x times time, which will equal our initial velocity times the cosine theta times time. Plug in our values. 12.5 meters per second times cosine of 30 degrees times 1.27 seconds. Our rider in this instance should be able to clear a gap of 13.7 meters. Hope you've enjoyed this episode of Mountain Bike Physics, Projectile Motion, Gap Jump.